friend of mine who works at Blue Sky right now. And they're doing really amazing stuff. And there's a whole bunch of other volume SOPs. Volume compressed SOP is one of the key nodes that made it in right at the last minute. It allows you to take any volume and compress it down. As a matter of fact, it even has controls over quantization. So you can take a 1 gig volume and you can compress it down to maybe 60K. And that can be passed through the various operators. Each operator will then dynamically expand that volume to its full depth, do its work at 32-bit, and then at the end of it, and when it's done, it'll recompress it down for you. And that algorithm is pretty fast, maybe not as fast as some of the custom stuff that's in some of the studios, but we're getting better. And for that, I just want to go and show you one more example in Houdini. It's probably my last thing. This is supposed to be my old school blog for this week, so you guys get an early notice on this. And when Jeff Late said to me, he's that one developer at Silex, it's just, you can see things that most people can't. He said I actually was able to read time objects. You can now, the SBlend now, he said, SBlend can now blend volume data. So I built this network. I said, oh gosh, now I can read time volumes. That was the immediate thing I thought, right? Because I know that that's a huge problem. So read time volumes, great. So I put in a primitive node, I put in a time shift, time warp. Time shift, by the way, for those that don't know, just allows you to shift time, and time warp allows you to warp time on geometry, so I can actually move the geometry around. And I wired it into the SBlend, and I did the $F minus 1, and Jeff said, no, there's the time warp. The time warp does this as well. As a matter of fact, any node that blends any data can blend volume data now. So I thought, time blend and time warp. So I cached a simple smoke simulation, and you can take a look here, press forward, space W. And you can see here, here's my regular smoke simulation. It's moving along pretty good. It's 80 voxels high. And then I go to the time warp, and I've created a little custom slider here. And you can see now that you can read time really slow. And you can go even slower, so 6. And all I'm doing is just using a simple expression in here, where I'm just multiplying it by the time scale factor in the output range. So I'm just remapping the output range for retiming it. And there you go. Yep. And I found out that you can retime, you can go really slow, about 6 times slower before it starts to really see the blocking and everything. And by the way, I'm retiming all the volumes in this low resolution simulation. And right now there's a whole bunch of volumes here. There's 7 of them. And you can see they vary in range. Mainly they're 80, some are half res. So retiming volumes, I'm going to cover that in the next little while and explain it in a little more detail. That's pretty cool. So that's one of those 20,000 features I talked about earlier on before we started. This is another quick file on, this is another really cool tool that we snuck in the last minute for a games company. We always wanted to do this, which is multi-resolution support for you aggregate all your volumes into a hierarchy, and then we will surface it with the new volume surface pop. And I'm going to cut this movie short. There you see, 2 volumes. We take 2 surfaces, convert them into volumes, merge them together, and then run them through the volume surface node. So I'm going to jump to the very end. There you go. So it's simply just node, 2 inputs. Left input is the volume you want to populate. Right is the volume hierarchy, and then below it you do a volume converted to polygons, and you can see we convert to a multi-res hierarchy. Yet another way to solve the near mid far problem and that whole multi-resolution thing. You can now use volumes. How many ways is there to do that in Houdini? We added another one. We have a volume visualize geometry node that allows you to composite volumes very effectively in the viewport, so you can actually see what's happening. And you get that from default when you put down the Pyro node from the shell. Another thing we did is we did voxel fluids, rotating, so we can actually now rotate a voxel grid to an animating truck. That just means less fluid loss, really, because the volume container can now travel with the object. And how many of you noticed that Houdini 11 has Y up now? Houdini has Y up. So next thing you know, we'll be adding units, but so fur, why? The big thing about fur is we've decoupled the guides from the geometry, plain and simple. So it allows you, we're heading quickly towards actual hair tools. We'll see if we get there in 12. Cloth. The current algorithm we written again, thank you. This time it's completely 100% our algorithms, and the two takeaways with that is there's an internal attribute now that allows you to completely eliminate stretching in the cloth, and there's no impact on performance, so you can do really stiff cotton-like materials. And the second thing is we have normal drag and perpendicular drag, so you can do some really cool stuff with that. Dive in and start playing with it. Lots of stuff. And here's a simple test. You know, we've heard lots of times, make your cloth faster, but when it's in high quality mode, just make it work. And so we're just doing the just make it work in this release. Light rendering, network rendering, texturing, p-text, stereoscopy, we're constantly working on that, pipeline integration. Lots of options in there. We've been very busy working on it. User interface, busy style connectors. That's the big thing for me. And the new tool palette. And that, basically what that means is you can use the gallery tool palette in any network and you can actually search. You see the filter in the bottom. You can actually type in the shirt string now. So you can see all, for instance, if you type in volume in there in SOPs, you'll get all the SOPs that relate to volume. There's crowds. I want to get to Mr. X because I got, what, 3-4 minutes left? Okay, 3 minutes. Mr. X. 5 years ago, if you would have told me they would be using Houdini, I would have said, ain't gonna happen. But I could probably have said that to a lot of facilities here in the UK at about the same time. Now, Houdini's all over their lighting pipeline. And I don't know what is it about me with clouds, but every time you introduce somebody to a little bit of a cloud thing in Houdini, all of a sudden the software gets adopted, they start hiring a couple of really good guys, the talent spreads. Before you know it, they're using us for lighting, for rendering, for visual effects. Pretty much the entire back end of Mr. X now is currently using Houdini, feeding into Mantra. And for those of you who don't know, single master license gives you an unlimited number of Mantra tokens. So in this case, all the clouds were rendered in Mantra, Mantra being our renderer. And one of those things that it's really good at is cloud rendering. And talking about innovation after we survived the release of Houdini 9 where we rewrote all the UI stuff, that was one of the first key innovations that we had worked on. And our render guy, Andrew Clinton, actually did a couple presentations at SIGGRAPH. He did another one this year. And again, his ideas and philosophies resonated with a lot of people. And probably look for those features that are in Houdini now and other renderers coming in the next release as well. Giving back, so to speak. And you can see here all the baked-in lighting information. In this particular shot, it was Houdini 10, so they were baking in a lot of information in the i3D format, which is similar to Brick Maps and RenderMan, if you're familiar with that. But with Houdini 11 now, if you haven't noticed, we've completely rewritten how volume data is saved inside of our BGO format. We have. And it's a lot more tile-based, a lot more like i3D. We'll still continue to support i3D as a format, but they also did Hot Tub Timer 3 Machine, and these are more, I'm going to have some presenters come on later, they're going to show you some of their work. This is more of the traditional Houdini type of X, tornadoes, lightning bolts, lots and lots of particles. And again, in this case, it was all rendered in Mantra, lit and rendered in Mantra. Their entire lighting team was moved over from Maya to Mantra. And I think it really was only about a week or two for the entire transition once they had all the tools built. More clouds, more tornadoes. I haven't seen this film, I don't know if I will. Oh, I can watch it on the plane that way, I don't have to inflict. It's a really cool film. And this is, Houdini is one of these tools, set replacement. As I said, a lot we get pegged into this VFX, and everything's VFX is simulation. Couldn't be further from the truth. VFX in Houdini means building anything from scratch dynamically. And the last thing I want to show you, there's some more particle-like stuff. Hey, particles. More particles. More particles. More particles. Rhythm and Hues. We were graciously, Rhythm and Hues allowed us to show this one last clip. Oh, did I spell it wrong? I'm sorry. I spelled it right there. I was in a hurry. Now, this shot was in the last sequence, and I did watch this in the back of a plane seat. I was sort of watching on the sides when Jeff Later, chief programmer, was working with the Rhythm and Hues team. And they were working with the three typical solvers, their own in-house fluid solver, a solver from a different package, and our pyro solver. And of course, the pyro solver team was just 2 guys. And in this case, the whole deal, the director wanted not only to have realistic fire, but he wanted to have control, implicit control, as to when he could see the character through the fire. And also when the character ran into the fire, they wanted to have control as to how the fire would flow around the character. So they just didn't want a fire sim. They wanted to have something that they had complete directable control, where you can see the silhouette of the character through the fire at all the time. And that was the goal. And out of that, they created a whole bunch of set of fire tools, which they used on Jackson and the Lightning Thief, I think. Yeah, the Fire Breathing Dragon, they used the same tools. They did a presentation for us in our LA launch at SIGGRAPH this year. So, and then finally, here's the early test. This is the test that Jeff Lake had done with a lot of the work that they had, just to get them going on the right field. Well, you can do some basic fire, and you can have it evolve around the character. So, there you go. With us, it's all about directability. It's all about not just doing a simulation, surviving that, and then passing it to lighting and rendering and hope it goes. With Houdini, the simulation is where it starts. And you do something which I call data mining. You data mine various volumes, and it's all done in the same session. And that's what I call playing with Houdini.